Silly.
That's just silly.
Say maths is cool or something.
Maths is cool or something. Right. Question 5. A random variable x has the distribution b 5 a quarter. That means there are 5 trials and the probability of success in each one is a quarter. Find e of x. Well, we just need to look up on the formula booklet, in that little table, it says e of x, the expectation of x is np. It's just 5 times a quarter. So we get 5 over 4 as our expectation of x. That's a bit of a gift. Right, part 2. Also on the formula booklet, it gives the formula for each individual one. The probability of x being equal to 2, according to the formula, is NCR, so 5C2, p to the power of r, so that would be a quarter squared, 1 minus p, so 3 quarters to the n minus r, the 3. And you think this through logically as well. This is just 2 successes, 3 failures. How many different ways can you arrange that? It gives you, I think, that 3 significant figures. If you write 135 over 512, that is also the right answer. There we go. Now it starts to get subtly different here. We've got 2 values of x are chosen at random. Find the probability that their sum is less than 2. Well, if the 2 are chosen, their sum is less than 2. That means they're either 0 and 0, or they're 0 and 1, or they're 1 and 0. It could happen in either of the orders. So we've got to work out the probability. These options are what we just said: 0 and 0, or 0 and 1, or 1 and 0. They are the 3 ways that we can get some less than 2. Hopefully we'll notice something about this in a moment as we work this out. So the probability of the sum being less than 2 is, well, 0 and 0. That would be, the probability of x being 0 is 3 quarters to the 5. Okay, because that means we have 5 failures, no successes. And that has to happen twice in 2 independent things. So we're going to times that by 3 quarters to the 5. That's that one sorted. Then we're going to add that one, 0 and 1. Well, 0 and 1 would be, that would be the 3 quarters to the 5 again, because we've got 5 failures. That's the 0 bit. And the 1 bit is 5 lots of a quarter times 3 quarters to the 4. Because that's 5C1, isn't it? And that one there, that one can happen in 2 possible ways. Because I've just written the 0, 1. We could also have the 1, 0. So we're going to times that second probability by 2. And if we add that together, we get 0.244 to 3 significant figures. Can I just show you something that's quite neat about this as well? If you look at what we've just added up here, we've just done, if we simplify what we've written, we've just done 3 quarters to the power of 10, and then we've added on 2 5s are 10 lots of 3 quarters to the 9 times a quarter. And that is exactly the probability of if y is binomially distributed with 10 trials and a quarter being the probability of success, that is equal to the probability that y is less than or equal to 1. And actually, if you think about it, that makes sense. We're choosing 2 values. Each one is from 5 independent trials. We want the sum of them to be less than or equal to 1. Well, that's like choosing from 10 independent trials, getting a sum that is less than or equal to 1. It's the same kind of idea that we're doing that. So it works out to be exactly the same probability. So you could have done it like that. You could have thought of it as being 10 trials. Part 3. Now, this one says 10 values of x are chosen at random using an appropriate formula to find the probability that exactly 3 of these values are 2s. Well, the probability, we've now got 10 values are chosen at random, so 10 independent trials, and the probability of a success isn't the quarter that it was before. A success is getting a 2 from our original deal. And from the original deal, the probability of a 2 was that number there. So we've now got, in part 3, it's all changed. X is now a binomial distribution, but the probability of the success is our answer from 1 part B, which was 0.264, 135 over 512. And we want to know the probability that y equals 3. You definitely can't use the tables for this one, because that probability isn't going to appear, is it? That is 10C3, 135 over 512 cubed, 1 minus 135 over 512 to the power of 7, because 3 out of 7 is 10. To calculate that, it's 0.258 to 3 significant figures. And that is that question. Oh yeah, and that's maths 100.